All right, today we get to solve two-step equations. We're moving on. We did solving one-step equations, adding, subtracting, multiplying, and dividing, and now we get to look at 7-3, which is solving two-step equations. Again, you get to choose if you are not understanding and struggling a bit, you might want to choose mild. Otherwise, if you'd like a bit of a challenge, you do medium. Our guiding question, we're trying to solve equations that require more than one step. And we're going to practice two-step. We're working our way towards being able to do multi-step equations. Just curious, have you checked out this book in my library? It's called Kiss My Math, showing pre-algebra who's boss. This one has a great section on how to solve two-step equations. And so I'm going to give Danica McKellar some credit here. This next activity or this thought process comes from her book. So check it out. All right, so we're going to think of wrapping a present, and we'll look at this more in class. But for right now, just think about this. If we think about how we would wrap a present, we would first maybe put the box on the paper. And again, you don't really think about this, you just kind of do it, but let's just step through the process. The first thing you do is pick out the paper, put it on the desk, and put the box on the paper. Then you're going to fold the paper, and then you'll tape it. And then you'll put a bow on that present if you are choosing to wrap it with a bow. If you have to unwrap that present, and let's say you're a person who really likes to save the paper, if we take it one step at a time, again, this doesn't always happen, but just think it through with me. The first thing, what would you do first? Well, you might take the bow off. So think about that as being your first thing. Take the bow off. Notice the last thing we did is the first thing we do to undo. And it's the opposite. Instead of putting it on, now we're taking it off. Think about the next thing. After you take the bow off, what would you do with the paper? And again, this is a person who likes to save the paper. They might take the tape off or untape the paper. Okay, so look at this. Again, the third step, or second to last, now becomes the second step. But instead of taping, we are untaping. All right, next, usually we would fold the paper before this, so we are now going to unfold the paper. We pull off the tape, then we unfold the paper, and then we take the box off the paper. So if you take a look at this, the steps to do a problem, PEMDAS, are now to undo, we have to work backwards. We take the last one and do it first, and then work our way to the first thing. But notice we do the opposite, or the inverse operation. So instead of putting the bow on, we're putting it off. Instead of taping, we're untaping. Instead of folding, we're unfolding. And instead of placing it on, we're taking it off. So that should be what you see when you think of how are these steps related. What does this have to do with solving equations? Everything. Let's take a look. And again, you're not writing anything yet, but you will very soon. So get ready with your packet. We are going to get x all by itself, but we're going to follow SADMAP or SADMEG. Instead of doing PEMDAS, remember we have to work backwards. So this would be the opposite of what we would normally do, or in other words, do what we normally do but backwards. And you're probably wondering, Miss Sandin, why are you even talking about this? I'm talking about this because we're solving two-step equations now. There's going to be more than one thing that we have to do, so we have to decide what to do first. The same rules still apply. We still have to, whatever you do to one side, you have to do to the other. That's the property of equality. Again, you don't have to write this down, but please lock this in your brain. And to take something off one side, you have to undo it using the inverse operation. And our goal is always to get x by itself, to know what the variable represents. So don't worry about this problem. Let's do the problem in your packet. Taking a look, you should be on the notes page in your packet. This is page 7. And I'd like you to take a minute and just write down these things that I have typed. So right here. Step 1A. Now we have a 1A instead of a 1, just a 1. And again, I apologize, I forgot to fix these. We decided to change it to grouping symbols instead of just calling it parentheses. Because sometimes it's parentheses, but other times it's more than just parentheses. All right, let's see if I can fix it. Well, it's kind of being difficult. So let's see. You can just write it as SADMEG. There we go. GEMDAS backwards. So step 1A, undo using SADMEG. Step 1B, undo again. And again, we're going through the order of operations backwards. So first we're going to add or subtract, then we're going to multiply or divide, then we're going to do exponents, and then we would do grouping symbols. Step 2, still get your solution. Step 3, check, and make sure you plug it in, plug it in. It gives you some hints up here to undo. Make sure you first do the adding or subtracting to remove the constant or the number, and then do multiplication or division. All right, so here goes. Draw the line, just like before. We want to get our x all by itself. If we think this through, and I'm just going to write it the first time so you have an idea. Remember our present. If we think through what we would normally do if this x were like 5. Let's say x were 5. Let's just write it out up here. Again, you don't have to write this down, but definitely keep this in your head. What would I normally do first? Well, I'd normally multiply. Multiply by 6. That's step 1. And then I would normally add 8. So to undo, we have to work backwards, like we're unwrapping the present. So instead of starting with multiply by 6, we're going to start with the adding 8, but we're going to undo it. So the inverse operation. So instead of adding, we are going to subtract 8. And now tell yourself what you would do next. Instead of multiplying 6, we are going to divide by 6. And I'm only writing it like that instead of a fraction in this case because it's shorthand. It's easier to understand. So think through this process each time. And you'll get faster and faster at it so that you don't have to write it down. But for now, we'll just keep that for notes. Okay, so again, it says to undo first using SADMEG. So we're going to subtract 8. And whatever we do to one side, we have to do to the other. 50 minus 8 is 42, and that equals 6x. Notice these 8's cancel out. So now, I divide by 6. That's what it says to do next. Please use a fraction bar, and now x equals 7. Very good. That's the solution, but I have to check my answer and make sure it works. So I'm going to write it over here. 6 times 7, that's our answer. We put that in parentheses, plus 8, and we ask ourselves, what is that answer? Okay, well, 6 times 7 is 42, plus 8 is 50. So check. We got it right. Box up your final solution because it's correct. Yay! Celebrate. Okay, looking at the next problem. We have to think out loud. Multiply by 2 would normally be first and then subtract 5. Multiply by 2, subtract 5. So instead you are going to start with the subtract 5 but do the opposite operation. So I'm going to add 5 and then instead of multiplying I'm going to divide by 2. All right, so let's do it. Add 5. Whatever I do to one side, I have to do to the other. Go ahead and do 11 plus 5 is 16. All right, and that equals just 2x. Now I divide by 2. Divide by 2. X equals 8. Check your answer. 2 times 8 minus 5. That is 16 minus 5 is 11. Yay! Box up your final solution. If this is too fast, you can always watch the video again. Please do all of these problems. Make sure you're confident, and if you're not, come back to me with questions. I'm subtracting first, because it says up above, oh yeah, I subtract first, and then remember to pay attention to the signs. This is the first one with a negative sign. It's multiplication, I do the opposite, and divide. I divide by negative 4. You don't ever mess with the sign of the number. You just do the opposite operation. I'm sorry, the inverse operation. I have to catch myself. I say it wrong sometimes. So 4 divided by negative 4 is negative 1. Try that. Negative 4 times negative 1 plus 9. I'm just using the original equation. That would be negative 4. Oh, I'm sorry. Negative 4 times negative 1 is positive 4. 4 plus 9 equals 13. Check. Yay, I got it right. Box up your final solution. Over here, this one's a little trickier because it's got the x after the number. So be careful with this one. I would do stay, change, change so that I don't mess it up. And then I might even rewrite it. This is negative 3x plus 7 equals 34. That way I make sure I don't make mistakes. So again, I did stay, change, change, which I can do anytime, and I see that, oh yeah, that's a negative 3x. I don't want to miss the sign. So I'm not going to add 7. I actually have to subtract 7 to get rid of it. Be very careful. So this is negative 3x equals 27, and then I divide by negative 3. Got to have that sign, negative 3. So x equals negative 9. If, when you do the check step, you plug it back into the original equation and you notice it doesn't work, remember to go back and check. Oops, sorry. Go back and figure out what you did wrong. So this is negative times a negative. Notice I said negative because that subtraction sign, I think of it like stay, change, change. Negative 3 times negative 9 is 27 plus 7 is 34. So check. Box up your final solution. You should be able to write a little bit neater than I can. I apologize. It's a little bit hard to write neatly with this Smartboard pen. I'll try this one. Okay, so again, we've got division. So divide by 2, and then we've got subtract 7. We need to do the opposite and do the last one first. So I'm going to add 7. I apologize, I said it again. I'm supposed to say inverse operation. And then multiply by 2. Okay, so add 7. X divided by 2 equals 16. Then multiply by 2. Multiply by 2. X equals 32. Check my answer, make sure it works. Try 32 divided by 2 minus 7. 32 divided by 2 is 16. Minus 7 equals 9. Check. Box up my final solution. Okay. Subtract 8, subtract 8. You should get to the point where you are really good at this. And again, you can always rewind if you feel like I'm going too fast and it's confusing. I'm multiplying because the opposite of dividing is to multiply. Then x equals negative 15. Pay attention to those signs. Plug it in, plug it in. Negative 15 divided by negative 5, that's 3 plus 8 is 11. Notice I can flip the order as long as I have everything the exact same. Check. Box up your final solution. With fractions, don't freak out when you see a fraction. Although I am going to make it easier to see what that fraction is. There we go. 3/5 x plus 22. I know I need to do add or subtract first, so I'm going to subtract 22. Subtract 22. So I have 6 equals 3/5 x. We learned this in 7-2 that you just multiply by the reciprocal because then these will cancel out. Multiply by the reciprocal. All right, so now x equals, oh, I got to remember to do 6 over 1. 6 times 5 is 30, divided by 3 is 10. So now I plug it back in and make sure it works. You can use a calculator for these. 3/5. You could even change that to a decimal, 0.6, if you want. But you need to make sure that it works. And then box your final solution. Okay? Subtract 1, subtract 1. I got to do the inverse operation. Again, I can't see that. So I'm just going to make sure that it's a 1. It looks like it. Yep. So I have negative 1/3 x equals, ooh, be careful, stay, change, negative 8. And then I multiply by the reciprocal, but it has to stay negative. Has to stay negative. So x equals, this is 24. Check it. So my solution, but I need to check. Negative 1/3 times 24 over 1 plus 1. So this is negative 24 over 3. You may not have space on your page, but you get to use your calculator. All right, then I divide. That's negative 8 plus 1, which equals negative 7. Check. Box up your final solution. That is solving two-step equations. You're awesome.